Hi, welcome to PA Tech Talk. In this episode we're going to look into interrupts. External interrupt created from the button that is available on the Nucleo boards. You normally have two buttons on the board, one black that is the reset and one blue that is a user button. You can use that for creating an external interrupt, normally a PC13 external interrupt, and then we also need to look into what callback functions that one triggers and how to use that in our code. I will be using the Nucleo G491 board, and you can use it for any board that you like, so that is no problems for you to use whatever you have on your desk. So let's start with the new project. Tag along. Here we have the STM32 Cube IDE, and I have updated it to the latest firmware available. So we will start a new project by going with File, New, STM32 Project. We hit the tab board selector, and in the commercial part number we write the name of the board that you have on your desk. I write the Nucleo board. This is this one, Nucleo G491RE. And if we just hit enter on the board there once, we get a menu up here. It says different tabs, but if we go under Docs and Resources, we get the schematics. And here we see that there actually are two schematics for this board, and there is the C04 and the C05. So there is a small sticker on the back of your board that identifies which board revision you have, and what I have is the C4, so I will just click on that one. Now that opens up and you get the schematics, and what we would like to view is the button. That is, if I can get that into screen here. So there you have the user button, the blue hat button, and we can see that they name it B1, and we see that it's normally pulled down by a 100k resistor to ground, so it's normally low. And the position for this switch is in the normally resting position, so it's a normally open position. And that one is then connected through this current limiting on 330 ohms and a low pass filter to the PC13 input for the microcontroller. So whenever you hit this one, this signal will go up to the VDD, so you'll get a high signal on PC13. So you put a trigger on the racing flank on that, going from 0 to VDD. And then we also need to find the LED. There you have the reset button, but we don't utilize that one. Where are the LED? Okay, here is the LED. So you have one LED, a green LED named LD2, and that has its anode through a resistor of 510 ohms up to 3.3 volt. That is current limiting the current going through this resistor. And it's turned off by this NPN transistor. So this one normally have his base down to ground, so it's closed. It doesn't run any current through the collector emitter here, unless you give it a signal on the PA5. So the PA5 is connected through this resistor here. So if you put the PA5 high, it will drive the base high and start conducting current from the base to the emitter, and also opening the collector emitter current, and the LED will start lighting then. So then we know that we need to put the signal PA5 to turn on the LED, so we'll need to put that high. Great, we don't need this anymore. We can go with next. and give the project a name. You can give it what name you want. And we hit finish. Okay, so now we are here, and we can start with look into the clock configuration. And in this case, we are not going to use or need the external clock, so we can use the internal high-speed oscillator here. So HSIRC. So we see that this one is connected to the PLL source multiplexer, and it goes into the multiplexer, and it's also selected there, and it creates a 170 megahertz in my case. I don't need so much, so I can just hit 64, and then it searches for a solution if it's possible, and then it calculates all the dividers and multiplexers multiplications to create this clock for us. So we use the internal, so we can disconnect the external clocks here. So we go under System Core, and for the clocks, we can then just disable these ones. And we can now look in the clock tree that these are now not any longer blue, they are disconnected. For the debug, we go under the sys, and there we see that the serial wire is enabled, and these 2 pins here is the serial wire debugger. Makes this possible to enter the code into the microcontroller. And just make some extra room there. And then we have some GPIO. We have the button PC13. So when I hit PC13 there, you see that this one is blinking. I can also write down here in the search, if I have many pins on my device, I can just write PC13 and that one starts blinks. If you have a device with many pins, it can sometimes be hard to find it, and that is an easy way to do it. So you can see on PC13 it says here external interrupt mode with rising edge trigger detection, and here we see that is the GP trigger motion trigger that we need. We can select other triggers if we want, but we remember when we looked in the schematics that it was a pull down normally, so whenever you hit that button you have a racing flag, a racing edge on that one, so that one is the trigger then. And you can also see if there should be any pull up or pull down resistors on the pin. That is not needed because there is already a pull down pin on the board. And there is a user label that you can change. So in this case it's B1 blue push button, and it's all reflected up here as well. And then we have the PA5. The PA5 is LED2, so that is the green LED. So that one was connected to the PA5, which we remember from the schematics as well. It says here actually that it is low for when we initialize it, and that is very crucial because sometimes you want it to be high when you reset it. In this case, if we put it high, it will be turned on from when we reset it, and we don't want that, so we keep it low. But keep that in mind, sometimes it could be useful to have the initial level set up from the very reset. And here we have an output push-pull, and we have maximum output speed that is very low, so we don't need very high drive speed on that one. Great, on the PC13 we had the interrupt. So if we click on that one and we go for the NVIC flag up here, we can see that the external interrupt line 15 to 10 interrupts are enabled, and this one is on the PC13, so it gives you an interrupt on the interrupt 13. So any interrupt from 10 to 15 will be generated on this one. We can also look here on the NVIC tab out here on the left. There you can get a little bit more information as well. Here again we see that this X line is enabled, so that is great. And you can also look in the code generation, that it's enabled there, and it's also an enabled code for it, and it calls the HAL handler for it. So not much more to do here, so we can just build our code. And what I normally try to do is just, when I have built a project, just created a project, just build it to see that there is no problems with it. And it says 0 error, 0 warnings. Great, so every error now from here on is something that I created at least, so that is good to know. What we can do from here, we haven't written any code in it. We can see if we can get the debugger to run with us. So the first time we hit this debug icon, you get this edit the launch configuration properties, and we hit the debugger tab, and we will go with the SVVD and the serial wire debug. So we hit that one, and we can scan if the controller, if it finds the Y link, or the ST link in this case, it's serial number. So if it finds that one, that's good. We just apply OK. And it tries to write this empty code to the download, verified successfully. And if we put the board in here as well, here you have the board, there you have the blue button, and there between are the LED. So if I now push the run button, there actually won't be any view. So we stop this one and try to make some code for us. We generate an interrupt when we push the button. So to capture this interrupt, we need to go into the core under drivers. There you have a folder called STM32 G4 HAL drivers in my case, and there you have the source. So there we have the HAL GPI C. So if we double click on that one, you see out here on the right, you have an HAL GPIO External Interrupt callback. So here we see, if we double click on this one, now we know that we are in this C file, and here we have an interrupt routine created for us for an external interrupt callback, but it's declared as weak, and this says that this function should not be modified. When the callback is needed, the HAL GPI AXTI callback could be implemented in a user file. Okay, so we copy everything except the weak and go back to our main C file. Very in the end, there is some user code where I normally put my interrupts. It's called user code begin for. So we put the callback function there. And notice that I didn't bring the weak statement with me. And it says here also prevents unused arguments compiling warning. So this is something that if you take that away, you will get some compiling warning. And this we can remove. So what we can do now is we can put a toggle breakpoint here, and we can just try to build the code again. And we can run the debugging. So when I now push resume, nothing happens until I push the blue button. Then we get halted here in this callback function. So if I just say resume, the code is running again until I hit it, then it stops here in the callback function again. So we know now that whenever we push the blue button, we will actually get a callback here. So we can take away that one and we can break that. So now we're back in the main C file. You will get this interrupt from amongst the blue button, but you can also get from others. So what we can do here is find out what had actually triggered this callback. So we write if the GPIO pin I can't write today, sorry for this. So if this one equals, and now we need to remember what we called the button. I think it was B1. Yeah, the B1 pin. So if it's the B1 pin, what should we do then? Then we maybe should toggle the LED. And we need to know what port, I think it was the LD2 GPIO port. And the pin was also LD2 pin. And we can't forget about this one. So, okay, so we build this one. Great. We haven't managed to make any errors so far. We build a project again. And we run the code. Now it's the first time we actually see the LED light. Great, so we can actually stop that one. One thing with interrupts is one normal error that you can do is that you put a lot of code in the interrupt. So whenever there is an interrupt, you will do a lot of stuff. It's not not recommended to have too much code in an interrupt. It should be kept as small as possible. So even if I'm just toggling a pin in this one, this is fine. But you shouldn't put too much code in the callback. So one thing that you can do is working with flags. So what I can do in this case, we can make an include. We need to have the standard booleans, and now we need to make a small variable there. So make a variable called button, and we initialize it with the value false. And we then go down to our interrupt routine that we have back here. And well, we can just delete that one. So whenever we get an interrupt callback and the pin is B1, we will button true. So that is what we will do here in this callback function. So it will just go here and put this button variable to true state. And it will go back to our main program again. That is not very funny to see. So what we can do here is we can look in our while one loop, because whenever you do something in this code, it will come down here and it will stop in this while one loop. It won't happen anything else there. It will be stuck here forever until you get an interrupt, and then the interrupt routine will be serviced, and then it will come back here again. So what we can do here is we can actually look for the value on the button. So we can say while button is not equal to true, it will just stay here. And this is not either a recommended way to write code, because you will waste all your CPU cycles in this loop. You won't do anything else, you will be stuck here. But in this case, just to make a point on how we can use the flag. So whenever that button is not true, that means it's false, it will stay here. But as soon as it's true, it will pass this one and go to the next statement. And then we immediately put it to false again. And what we else can do is now turn on the LED so we actually can see what is happening. And that was the port pin, and now we port, and now we need to have the pin as well. Like so. So whenever the button is not pressed, it will just stay here. And as soon as I push the button, the callback function will put the button to true, and then it will pass this one and go to the next statement where I will put it to false immediately. And then it goes to the next statement. It will toggle the LED pin, and then it will come down here and it will stop again. So it will wait for the next trigger. That it is at least the theory. Now we'll see if that works in the real world as well. Okay, so we push there, and okay, so now we have done this small experiment and a small elaboration with the external interrupts. Hope you liked it, and if you learned something, please give it a thumbs up, and if you're not a subscriber, please consider to do so. It's really appreciated, and if you have any thoughts, give me something on the chat line also. So until the next time we see each other, stay safe.